All right, so this is day 14 of coding every day until I get employed. So again, I'm doing another LeetCode problem. And today's LeetCode problem is LeetCode 1493, longest subarray of ones after deleting one element. So for starters, I got this solution from, I got it from this YouTube video right here. So I'll just be trying to explain it to the best that I can. And yeah, we'll see how well that goes. So given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in the resulting array. Return 0 if there is no such subarray. So firstly, we're just thinking, okay, well, we just want to return the longest array of ones we can get if we delete one element. And then, yeah, from there, that's where we start thinking about how we can apply this to what we know is a sliding window problem. So, what I think the thought process should be is, well, we know like we really want to consider zeros, and zeros are going to be like the main thing you want to delete, because if you have an array with ones and zeros, you want to delete you want to delete at least one of the zeros, because then that way you can find your longest subarray of ones, right? And then so basically what this code does is that you start each subarray after each occurrence of a zero, and you consider the array later on. So like with the code, right? So you have a max length that you're recording, and then you have a start, which is a zero, and you have a zero index. This is an index, so that's why it starts at -1, because you have nothing that was indexed to a zero yet. So then you loop through the length of nums, and then you say, okay, nums at I is equal to 0, right? If nums at I is equal to 0, then your start is going to equal to 0 plus 1. So you basically say, okay, we're going to have the start of our subarray be after an occurrence of a 0, the previous occurrence of a 0. And if there wasn't a previous occurrence, then you're just going to start at 0. And then you set the 0 index to I, right? And then what you do is then you consider the max length, and you say, okay, well, take the max length of your previous max length, and then I minus start. And the reason why this is I minus start instead of I minus start plus 1 is because we know that in every case we're going to end up deleting at least one element, so we don't want to consider another element. So for example, like if we had an index if we started at 0 and then I was at 1, you would think, oh, it needs to be 2, but in this case we're always deleting at least one element from it. It doesn't have to be 0, so that's why you would want it to stay as 1, and that's what that part of it does. And so yeah, I hope that made some sort of sense. That's what I kind of got from it. So yeah,